Hey everybody, and welcome to this explainer. I am just beyond pumped to have you here today. Listen, I've been in the networking industry for over 30 years now. I'm talking working in the trenches, designing massive enterprise architectures, and configuring Cisco devices since way before many of you even typed your very first ping command. And today we're tackling a topic that frankly strikes fear into the hearts of a lot of networking students, but it is the absolute lifeblood of a working engineer. We're talking about IP subnet design, and we are going to break this down exactly the way you will use it in the real world.
So picture this. Here is the ultimate question, and honestly, the very reality you're going to face out there in the job market. You walk into a brand new job and the senior architect hands you a single Class B private network, say 172.16.0.0, and they look at you and ask, how do you take this one massive, completely unusable block of IP addresses and perfectly slice it up to fit every single branch office, every VLAN, and every point-to-point link in our entire enterprise? And here's the kicker, folks. You got to do it without wasting IP addresses and without breaking the routing table. If you can answer that question, you are invaluable. If you can't, well, you're probably not getting the job.
To really understand why this is just so absolutely critical, let's look at the alternative. If you just take thousands of hosts and dump them into one massive unsubnetted broadcast domain, man, you get broadcast storms, massive security risks, and just sheer unadulterated chaos. It is completely unmanageable. But the market reality? It requires cleanly subnetted VLANs. By subdividing that massive network, we get tightly controlled traffic, structured IP routing, and actual isolation between departments. Subnetting is literally the tool that transforms all that chaos into clean, market-ready order. Okay, let's dive into this. Think about those massive bundles of cables you see in a typical data center. I mean, that physical infrastructure is really just metal and plastic until we come in and apply a logical, organized routing topology to it. When you're out there in the field, you've used subnetting to bring order to that physical mess. We logically group specific hosts together, maybe that's an entire floor of an office building on one VLAN, and we assign them their own dedicated subset of addresses. Now, to actually design these clean, organized subnets, we don't just guess. We rely on math. But hey, don't worry, you do not need a PhD in computer science to pull this off. There are really just two mathematical formulas that every 30-year veteran relies on a daily basis. I like to call these the golden formulas of networking. Whenever you're faced with a design requirement, these formulas right here are your starting point. So let's see how they actually build out our network design. All right, step one. To find out exactly how many subnets you can create, you use the formula 2 to the power of s, where s is just the number of subnet bits you decide to borrow. Step 2. To find how many individual hosts fit inside each of those subnets, you use 2 to the power of h minus 2. H represents your remaining host bits. Now you might be wondering, why in the world must we subtract 2? Guys, this is a real-world, high-stakes rule. In every single subnet ever created, the lowest number is reserved for the subnet ID, and the highest number is reserved for the broadcast address. Neither one of those can be assigned to a PC or a router. If you forget to subtract 2 in a live design, you might literally leave a critical device without an IP address. Because these formulas rely so heavily on exponents, I'm going to give you a piece of advice that has saved me countless hours over my career. You absolutely must memorize the powers of 2 up to at least 2 to the 8th power, which is 256. Trust me on this. When you're in a high-pressure job interview or a core network is down and you've got a manager breathing down your neck, you do not have time to pull out a calculator. You need to instantly know, in your gut, that 2 to the 5th is 32 and 2 to the 7th is 128. This is just non-negotiable for fast, on-the-fly subnet design in the real world. Now, once you've picked your mask, how do you actually list out all the subnets? You know, textbooks love to teach you to convert everything into these incredibly long, tedious strings of binary ones and zeros. And look, that is great for theory, but out in the field, we simply do not have time for that. So I want to introduce you to a veteran's secret weapon. It's a shortcut so powerful, it is literally going to change the way you look at networking forever. I call it the secret of the Cisco magic number. So the crucial point is understanding what this magic number actually does for us. By definition, the magic number is simply the value you get by taking the number 256 and subtracting your Subnet Mask's interesting octet. And that's just the octet in the mask that is neither a 255 nor a 0. That single, simple piece of subtraction gives you the exact increment, the precise block size that separates every single subnet in your entire design. It is the ultimate shortcut. Let's actually put this into practice, okay? Say we have a mask of 255.255.255.224. That fourth octet, the 224, that's our interesting octet. So, 256 minus 224 gives us our magic number of 32. Boom! Our very first subnet, the 0 subnet, starts at 0. To find the next subnet, we simply add that magic number to our interesting octet. 0 plus 32 is 32. The next subnet starts at 64. The next at 96. And just like that, without doing a single agonizing binary conversion, we have effortlessly sliced our network into perfectly sized blocks. But hey, designing a network is really only half the job. Once it's built, you have to support the thing. As a junior engineer, you're going to spend a massive portion of your time in the operational troubleshooting phase. Someone else designed the network years ago, and now you have to figure out how it actually works. When you get an IP address from a struggling host, you need an incredibly fast way to calculate the subnet ID it belongs to. To do this rapidly, you follow a very strict mental checklist. First, identify the IP and the mask. Second, find your magic number. Then, you just find the multiples of that magic number to locate the lowest number in that block, which is your subnet ID. Once you have the ID, you can easily find the broadcast address right before the next subnet starts. And guess what? Your usable hosts are sandwiched right in between those two boundaries. Knowing how to quickly find the resident subnet of any IP address is an absolute essential skill. It's exactly how you verify if the network is actually working the way it was designed to. Let me tell you a quick story from the trenches. Years ago, I get this urgent support ticket. A frantic user is complaining they couldn't reach the main server. They gave me their IP address, 172.16.150.41, with a mask of 255.255.192.0. Now, physically tracing cables wasn't going to help me here. I had to instantly run the magic number in my head. 256 minus 192 is 64. So my subnets are 0, 64, 128, 192. 150 falls perfectly right between 128 and 192, so the resident subnet ID is 172.16.128.0. That instantly told me exactly where to look in the routing table to fix the issue.
Now we've done all the math, we've done the theory, but none of this matters if you can't actually type it into the gear, right? It's time to take our logical math and translate it directly into the command line interface, the CLI, bringing our theoretical subnets to life on actual Cisco routers and switches. I want to show you the specific commands you're going to type literally thousands of times in your career.
Now, what's really interesting about this slide is how simple, yet totally fundamental this command is. IP address, followed by the actual IP and the subnet mask. You type this directly into interface configuration mode. This is exactly how you assign a specific IP from your newly minted subnet to a router's physical or even virtual interface. Burn this command into your memory right now, because without it, your device simply cannot communicate on the IP network. Next up is an absolute powerhouse of a subinterface command, encapsulation.1q VLAN ID. Remember earlier when we talked about chopping our network up into smaller subnets? Well, we usually map each one of those subnets to a specific VLAN. This command is the glue. It tells the router to use 802.1q trunking to tag traffic for a specific physical VLAN. It literally ties your beautiful logical subnet math directly to the physical layer 2 infrastructure. And finally, we have IP routing. This is an absolutely crucial global configuration command. Look, layer 3 switches are amazing devices. They can act as both switches and routers. But straight out of the box, their routing brain is completely turned off. Typing IP routing breathes life into that layer 3 switch. It activates the routing table and enables it to actually start routing packets between all those separate subnets we just finished creating. So look at that. We have actually come full circle. We started with this totally chaotic, massive, unsubnetted IP block, and we've walked through the exact steps a 30-year professional takes to team it. Let's look at the grand finale here and connect all the breadcrumbs together so you have a really solid mental framework moving forward. And this brilliantly illustrates our entire workflow. It follows this exact path from start to finish. We didn't just guess, we systematically analyzed the enterprise needs. We used our golden formulas, 2 to the h-2, and 2 to the s, to mathematically pick the perfect mask. We used the magic number to rapidly, effortlessly slice the network into clean pieces. And finally, we actually implemented that design onto the hardware using vital CLI commands. We successfully turned a massive, totally unusable network into a highly functional, tightly controlled enterprise topology. But wait, before we wrap this up, I want to leave you with a bit of a provocative thought. Throughout this whole explainer, we assumed every single subnet was the exact same size. But think about the real world for a second. What happens when you have a massive data center needing 1,000 IP addresses, and right next to it, a tiny point-to-point router link that only needs exactly 2 IP addresses? Using the exact same size subnet for both would be a massive, unforgivable waste of IPs. The answer to that little puzzle is variable length subnet masks, or VLSM. And mastering VLSM, well, that is your next huge step into becoming a top-tier Cisco engineer. Until next time, keep learning, keep configuring, and I'll see you in the next explainer.